What funny thing can I say about similar polygons? They're just so serious. Yes, they are, guys. Hey, welcome back from spring break. Let's jump right into similar polygons. So this is a picture of an M1A1 Abrams tank, and it's seen service in places like Iraq and Afghanistan. It served our country as a weapon of, well, kicking some ass, basically, for our American military. Anyway, this is one tank, but the difference is this. This may have only seen action on a shelf in your room. So models are excellent real-life examples of similarity in action. So what is similarity? Well, basically, let's start with the topic of similar polygons. And similar polygons have the same shape, but not the same size. So their shapes are they're almost identical. They are identical in shape, but they don't have the same size. So two polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So if you look here, ABCD is similar to EFGH. Now you'll notice the symbol for similarity is a little bit different than other symbols. It's the top part of our congruence symbol. It's that little, it's just that what they call the tilde. Anyway, so you'll notice that it's here on our congruence symbol, but there's no equal there. So this is very, very important that we put these markings correctly on quizzes, tests, homework. Get in the habit doing your homework with the proper symbols. So we can see here that the corresponding angles in our similarity are angle A is congruent to angle E, angle B is congruent to angle F, angle G is congruent to angle C, and angle D is congruent to angle H. But what's interesting is if I take AB over EF and BC over FG and CD over GH and AD over EH, they all come out to 2 over 1. 5 over 2.5, 2 over 1, or 2. 3 over 6, excuse me, 6 over 3, 2. 7 over 3.5, 2. 4 over 2, 2. They're always going to be proportional. Oh, okay, so if triangle FGH is similar to triangle JKL, list all pairs of congruent angles and write a proportion that relates the corresponding sides. Now this can be done by looking at the names. The names are very helpful, okay? So one of the things we can do is we can match up each of these angles. So all the angles have to match up properly. So angle F is congruent to angle J, angle G is congruent to angle K, and angle H is congruent to angle L. It's just like regular congruence statements, okay? So there's no difference with that. But now, when we're trying to set this up for a, to do our proportions, nope, hold on here. So when we're trying to do our proportions, we can still look at those names. So triangle FGH similar to triangle JKL. Here's one of the things we can do. We can take our, so segment FG has got to match up with segment JK. Segment GH has got to match up with segment KL. And segment FH has got to match up with segment JL, or LJ in this case. And you'll see how they've written those proportions. And those would all come out to the same equal value. So the ratio of the lengths of the corresponding sides of two similar polygons is what we call the scale factor. If you remember the picture we had of the model of the tank, sometimes these models will have a scale factor and they'll say 1/32nd scale. So that means every single measurement on that model is 1/32nd of the actual size of that real life tank. So in this case, triangle CAT is similar to triangle OGD. Yeah, I know you wanted to make it dog, but no, it's OGD. Anyway, the scale factor of triangle CAT to triangle OGD is 16:4 over, which is equal to 12/3, which is equal to 8/2, which is 4. So that's the scale factor. It always goes in the direction that we see from here to here. So whatever's on the first goes on the top. Whatever's the second value goes on the bottom. Okay? Okay. So if we have two polygons that are similar, then their perimeters are in the same proportion as their scale factor. So let's take a look here. We can see that the scale factor of CB to ON is 3:2. Now, the perimeter of quadrilateral ABCD is 24. The perimeter of the quadrilateral MNOP is 16. Well, if you'll notice, 24/16 is equal to 3/2. So the perimeter is at the same scale factor as any of the segments, okay, that we can derive. All right, so if triangle JFGH is similar to triangle JKL, lists all the pairs of congruent angles. So we pretty much did this earlier, but we would just say, again, angle F is congruent to angle J, angle G is congruent to angle K, angle H is congruent to angle L. And then we can write a proportion that relates to corresponding sides. So again, just to reiterate this, we would say that FG, the first two on the left, over JK is equal to GH over KL is equal to FH over JL. So you'll be asked to do this on a quiz. So make sure you set this up properly. All right, so we're given this diagram here and we want to find the missing measurements. Okay, so the thing I try to do with this is I want to set this up in such a way that I can solve it easily. So I know that FD matches up to YZ. So I'm going to put a little like this. Okay, now I've got to figure out whether VZ, okay, matches up to CD or VZ matches up to AF. Well, VZ are the first and last, so that's going to match up to AF. So I'm going to put two of these here. And I'm going to do that there. The reason I use the squiggly lines because if they're straight lines, then that means congruent. So I know that my scale factor is 6/9, which is equal to 2/3. So now I can just use proportions. So let's go solve for x. So 2/3 equals, all right, smaller over larger, so 10/x. So 2x equals 30, therefore x equals 15. Again, we're going to go, this is the smaller, this is the larger, is 12. So 2/3 equals 3y minus 1/12. Because you've got a little situation here, we may want to take then distribute this 3y minus 1, and that's going to equal 24. So 3 times 3y is 9y minus 3 equals 24. I'm going to add 3 to each side. 9y equals 27. Divide each side by 9. Y is equal to 3. Okay, again, triangle JLM is similar to triangle QST, so you want to match up appropriately. So JM matches up to, so this matches up to this. So our scale factor is 4/2, which is 2. Okay, or you can say 2/1, which would probably be smart. So now JL matches up to QS. So JL matches up to QS, and then these two here. I just circle the last two. Okay, so I'm going to say that let's go solve for Y, because I feel like doing that one first. So 2/1, so larger over smaller. So this is JL is the larger. So 3y minus 2 over 5 equals 2/1. So cross multiply, I end up with 3y minus 2 equals 10. So 3y equals 12, which means y is equal to 4. Over here, we're going to do the same thing again with 6x minus 3 and 3. So 6x minus 3 over 3 equals 2/1. Cross multiply. 6x minus 3 equals 6. Add 3 to each side. 6x equals 9. X equals 9/6, which reduces to 3/2. Okay, so we want to find the scale factor and then the perimeter. Well, ED matches up to ST. That's not going to help. We don't have anything there. So AB matches up to QR and QP. That's not going to help, right? So we know this is 8, this is 4 by the markings. If this is 3, this is 3. So we know that 3 and 4 matches up, so 4 over 3. So the scale factor is 4 over 3, because those are the ones that match up, like RS matches up to AE. Excuse me, RS matches up to CD, which is equal to AE, right? So this matches up to this. So our scale factor is 4 over 3. So if this is 6 over ST, so ED, so 6 over ST equals 4 over 3. So 4ST equals 18. Divide each side by 4, ST equals 18 over 4, which becomes 9 over 2, which is 4.5. Right? So the same thing, we're going to do the same thing with this and this, right? So, don't put 9.5 here. So I'm going to take 8 over RQ equals 4 over 3. 4RQ equals 4RQ would equal 24. My bad. RQ equals 6. Now I'm doing this the long way. So 6 and 6 is 12, plus another 6 is 18, plus 4.5. So this one here is 22 and 1/2. Add these up over here. 8 and 16 is 24, plus 6 is 30. Now the other thing you could have done is, once you figure your scale factor, you could have solved for this perimeter here and then use that with the scale factor. So either way of solving this is valid.
That's all, folks.